Hi everyone, my name is Dr. Kate and I am a chemical engineer.
So what is chemical engineering? Chemical engineering is one of the coolest types of engineering because we get to work on all sorts of things. You can work in the gas and oil industry, making fuel for your car, airplanes, and even your grill. You can work in a biology-focused area, making medicine, or making plant-based fuel. You might make things that you use every day, like food, toothpaste, or even your phone. You can even work with computers as a chemical engineer, modeling different types of processes, big or small. There's no limit to what you can do as a chemical engineer.
Today we're going to talk about soap. Let's do a little kitchen experiment first. You can go ahead and do this along with me as long as your parents say it's okay. We're only going to need a couple of things for this experiment. The first is going to be some oil. You can use vegetable oil, olive oil, pretty much any kind of oil that you can find in your kitchen. The next thing we're going to need are two clear water bottles. They don't have to be the same size. You can use plastic or glass, anything that you can see through. It's really important that these water bottles have lids. The next thing we're going to need is just water from our faucet. Lastly, we are going to need some soap. I'm going to go ahead and use dish soap, although you should be able to do this with different types of hand soap and things like that. I'm also going to use a little bit of food coloring, but you don't need it in order to do this experiment. The first thing that we're going to do is we're going to fill up both of our water bottles with mostly water. We don't want to fill them all the way up to the top, but I'm going to fill mine to about here. So we're going to want to try to get them about the same amount, but it doesn't have to be exact. So I'll pour a little bit out there. These look pretty good to me. This is where I'm going to add in a little bit of food coloring if I've decided to use it. Again, you don't need food coloring to do this experiment at home. Picked red for Wisconsin Badgers. So I'll kind of swirl that around, make sure it gets nice and mixed in. Give that a second to settle. Then what I'm going to do is I'm going to add a little bit of my oil. And again, we don't want to necessarily fill it all the way up to the top. We want to leave just a little bit of space, and we want to get about the same amount. So here's water bottle number 1. And here's water bottle number 2. The last thing we're going to do is we're going to put soap in one of these water bottles. Okay, not both of them, only one of them. So you can put as much or as little soap as you want. I'm going to put in quite a bit of soap. So we'll see the height of our liquid go up quite a bit. All right, now it's important to make sure that we get our lids on really nice and tight. And what I want you to do is I want you to shake these up. So we can see right now that our oil and water are not mixing, and we're going to shake it up and see what happens to the one with soap and the one without soap. You can come back in about 5 minutes. If you get really impatient, you can come back in just a couple of minutes, maybe 2 or 3. All right, we've passed about 5 minutes, maybe a little bit more than that, Let's take a look and see how our water bottles with soap and the water bottle without soap are doing. So this is the one that we had without soap. If you can see, most of the oil has kind of come up here. It might look a little bit cloudy, but if you wait a little bit more, I bet we'll see something that's pure oil up at the top and pure water down at the bottom. If we look at the one with soap, we see that there's a lot more mixture up at the top and kind of cloudy looking water down here at the bottom. If we wait a really, really, really long time, we're still not going to get something that's all oil at the top and all water down at the bottom. I did this experiment a couple weeks ago. So this one is just oil and water. So you can see up at the top, we have just oil, and down here, we have nice clear blue water. Here's the one that I used with soap. The water down here is still kind of cloudy. Some of the oil is still kind of stuck in the water, and we have some water particles and soap particles stuck up here in our oil. Let's talk about why this happens.
Let's show our water molecules as this Mickey Mouse shape and our oil as this three-armed shape. We can describe the water molecule as hydrophilic, which means water-loving, and our oil molecule as hydrophobic, which means that the molecule is scared of water. This means that if I have a water molecule and I put more water molecules around it, all of these water molecules are going to be happy because they're surrounded by other water-loving molecules. If I have an oil molecule and put more oil molecules around it, they'll also be happy since they're surrounded by molecules that are also scared of water. But if I have oil molecules and try to put water molecules around them, no one is going to be happy because I'm putting water-loving and molecules that are scared of water together. So they separate themselves out so that all the water-loving molecules are together and all the molecules that are scared of water are together. Soap is a special kind of molecule that has two parts, a hydrophilic part that likes water and a hydrophobic part that is scared of water. It gets along with both water and oil and can actually help them get along with each other. Now, all soap molecules don't look the same. The molecules in your dish soap look different than the molecules in your laundry detergent, your hand soap, and even your shampoo. The water-loving part of the molecule hangs out with the water molecules, and the part that doesn't like water hangs out with the oil molecules. These soap molecules are pretty happy doing that. The water and the oil molecules can even get along for a little while. Eventually, they'll want to separate, but that happens much, much slower than if soap wasn't there to help them get along.
I hope you had fun learning something new today. Thanks for listening.